This video is going to cover the topic of the shape of data. Be sure the date and topic are at the top of your page. The essential question for this video is how can we describe the distribution of data by looking at its shape? So be sure to have that written down as well. And we have talked about different ways that we might display data. Two of those ways are with dot plots or line plots and histograms. But when someone is looking at our data, right, when it's all graphed out, how do we describe it? What do we use to describe what we call the distribution of the data, where it lands on those charts? Take a look at this dot plot here of the age students learned to ride a bike, right? So we did a survey, we asked a bunch of students what age they learned to ride a bike, and the data here is displayed in our line plot, in our dot plot. What I can see right away is that there's two kind of sections of data, right? There's some data here between 3 and 8, and there's some data here between 11 and 14. So lots of students learned between the ages of 3 and 8, and the others learned between the ages of 11 and 14. We would call each of these a cluster, right? And we can kind of think of that word before, right? Or we've heard that word before. A cluster, things are kind of grouped together. So a cluster is a grouping of data, right? Where some of the data is kind of packed in together. And for some reason here, between these ages 9 and 10, no one reported learning how to ride a bike. There's nothing there, right? We can call that a gap. You can probably sort of infer what a gap would be, right? But a gap would be that sort of open space between data where there's nothing filled in there, right? That would be considered a gap. There's no data points. So things we look for when we look at graphs are clusters and gaps. Those are things that help us decide where a lot of the data is, where things are missing, and what we can learn from that. This graph is showing us the number of visits. I should label that down here. Number of visits to the water fountain students take per day at school. Then this one, I'm going to point out a different way that we might describe the data. And this time I don't see any gaps or anything like that, but I do see, if I sort of build this up and kind of trace it, I see that the number kind of goes up as we ask students until we get to 3, and then it sort of falls back down. It looks kind of like a mountain peak if I trace the outline of the data. And in fact, that's what we call this. That spot right there where we have 3, the number of students who went to the water fountain 3 times, is the peak of the data. It happened the most often. And peak is another term that we want to make sure we know as we're trying to describe data. We'll see that used as we talk about it, and we'll want to use that as we describe data that we've collected. This graph has some data between 1 and 4 about the number of student pillows that students have on their beds. And there's no gap, there's no cluster, there's no peak, right? If I were to outline this, this is kind of like this is the highest number, but it doesn't really stand out, right? 2 doesn't stand out as anything really that much more frequent than any other data point. In fact, the results for all of the responses 1, 2, 3, and 4 are fairly similar. And when the results are sort of the same across all of the data points, we call this uniform. And it doesn't mean that it's like perfectly level. It's not perfectly even among all of the responses, but it's pretty close. So uniform, of course, we think of as something being all the same. So it's almost like the results for all of the response options were similar. This line plot shows the results of asking teachers how many miles they ran, let's just say yesterday, right? And so you can kind of see, if I trace this out, that there's again a little bit of a peak here at 3, but I'm noticing something else, and that's that it's almost balanced kind of down the center, right? It's almost like it goes up by a certain amount and then falls back down. And you might think of that as sort of symmetrical, right? If you've worked in art ideas, right? Symmetrical being the same on both sides. So this is balanced data, and it's kind of similar on both the left and right. It's not perfect. Again, this doesn't mean it has to be exactly the same on both sides, but it's pretty close, right? When you look at it, it looks symmetrical. And this last example of how we might describe data, I'm going to compare these two graphs. And these two are quite the opposite. Well, not necessarily the opposite, but they're certainly not symmetrical at all. So we're going to describe these in a different way. And the way to describe both of these might be with the word skewed, right? And you might think of something being skewed if you hang a painting up on the wall and it's kind of crooked. You might describe that as skewed. Skewed is when there is more data heavily on one side than the other. So you can see with our cookies graph, right? It's kind of really clustered there on the left-hand side, and then it kind of trails down to the right. And it's the opposite here for our apples, right? It kind of is really high here on the right, and then it skews down towards the left. One way people describe the knowing how to define which is skewed left and skewed right is kind of calling this line that we've traced down here the tail. And so the skewed right has a tail that kind of trails off to the right, and the skewed left has a trail that falls down to the left. So just kind of keep that in mind when you're comparing the two. As we get to the your turn, here's just a little kind of word bank of the words that I use to describe some of the data. And I'd like you to use those words to describe this graph about the age of teachers. And so you can talk about whether, if there are any clusters and where they might be, if there's a gap, if there's a peak, if it's uniform, if it's symmetrical, if it's skewed one way or the other. Write down what you notice or label this however you think you can best to describe this graph. And remember, that was the essential question, right? Practicing how to describe the distribution of data when we look at a graph. And now we have some words that we can use to do just that. Be sure to bring notes and make sure you have these all drawn out nicely as visual examples for yourself in class.